Welcome students, myself Rebecca De Monte. Today we are going to discuss chapter 4 of geography, that is air pressure, module 1. Students, our learning objectives for today will be: what is air pressure? Here we are going to discuss about air pressure. We are also going to learn the relationship between altitude of the region and air pressure, also the relationship between air temperature and air pressure, and lastly horizontal distribution of air pressure. To understand what is air pressure, you need to perform this activity. Take a stick from a broom or a paper or plastic straw. Tie a thread at its center and hang it so that it remains horizontal. Tie two rubber balloons of the same size at the two ends of the stick. See to it that the stick remains horizontal. Now remove one balloon, inflate it and tie it again at its original position. Does the stick remain horizontal? No, the stick goes down on the side of the inflated balloon. This means that air has weight. Air is a mixture of gases. Therefore, like all other matter, it has mass and weight. So, from this activity, we understand that air has mass and weight, and all matter that has mass and weight exerts pressure. Therefore, air too exerts pressure. First, let us discuss what is air pressure. The air around us has weight and it presses against everything it touches. That pressure is called as atmospheric pressure or air pressure. So now, if I say we are continuously under the pressure of air, would you believe me? Most of you will say no. That is because we don't feel the pressure. So it is difficult to believe. But it is true. We are continuously under the pressure of air. Then why don't we feel it? That is because our body pressure and air pressure in the surrounding balances each other out, and so we don't feel it, but it is present. Similarly, the air in the atmosphere exerts pressure on the surface of the earth. Due to this air pressure, various phenomena like storms, precipitation, etc. occur in the atmosphere. Atmospheric pressure is commonly measured with a barometer. So this is the instrument with which air pressure is usually measured. Air pressure is measured in units of millibars. Do you know, students, all things in and on the earth stay earthbound because of the earth's gravity. This includes air which is in the gaseous form. Due to earth's gravity, Air is pulled to the Earth's surface. That is why air pressure is maximum at sea level. Note that air exerts pressure on everything and everyone, including us. It is believed that the weight of the air column on any one person's head amounts to 1000 kg. There are variations in air pressure. Air pressure is not uniform on all places on the Earth's surface. That means at some places the pressure is high and at some places it is low. Air pressure keeps on changing from time to time. This means at a time the pressure of air in a place is high, but some other time the pressure of air at the same place is low. The altitude of a region, temperature of the air, and amount of water vapor in the air are some factors influencing air pressure. Altitude of the region and air pressure. Now let us see how height of a surface and air pressure are related to each other. Air pressure is highest at sea level and decreases with height. Here, the Earth's surface that is in level with the sea experiences high air pressure, and as we go up, the pressure of air goes on decreasing. The proportion of dust in the air, water vapor, heavy gases, etc. is higher in the air closer to the surface of the Earth. This proportion decreases with increasing altitude. As the pressure decreases, the amount of oxygen available to breathe also decreases. At very high altitudes, atmospheric pressure and available oxygen gets so low that people can become sick and even die. Mountain climbers use bottled oxygen when they ascend very high peaks. They also take time to get used to the altitude because quickly moving from high pressure to low pressure can cause decompression sickness. Decompression sickness refers to injuries caused by a rapid decrease in the pressure that surrounds you, of either air or water. There are two reasons why air pressure decreases as altitude increases: density and depth of the atmosphere. First, let us talk about density. Most gas molecules in the atmosphere are pulled close to Earth's surface by gravity. So gas particles are denser near the surface. With more gas particles in a given volume, there are more collisions of particles and therefore greater pressure. The depth, that is distance from top to bottom of the atmosphere, is greatest at sea level and decreases at higher altitudes. With greater depth of the atmosphere, more air is pressing down from above. Therefore, air pressure is greatest at sea level and falls with increasing altitude. On top of Mount Everest, which is the tallest mountain on earth, air pressure is only about 1/3 of the pressure at sea level. So from this we conclude that as we go up, air pressure comes down. Air temperature and air pressure. Temperature and air pressure are closely related. Let us see how. Wherever the temperature is high, the pressure is low. Also, horizontally, the distribution of air pressure is influenced by temperature. Here, temperature plays an important role. To understand the role of temperature, first, you need to know that the flow of air is from high pressure to low pressure. Now, when air is heated, it expands, becomes lighter and goes up. Here what happens is, due to heat, the air masses on the surface heats up and expands, and they start to rise up. That is because whenever air masses heat up, they become lighter in weight, and so they start rising up, creating a low pressure at the surface of Earth. For example, let us take the experiment given in your textbook, which is of flying lantern, wherein the air in the flying lantern gets heated once a candle is lit. The hot air expands, becomes lighter and starts moving up. Therefore, the lantern is also lifted up towards the sky. So similarly, air masses on Earth's surface becomes lighter and move up, creating low pressure. Next, cold air is denser and heavy, tends to sink down. Now here what happens is, when the temperature is low, the air masses becomes dense, which creates high pressure. So the surface where air pressure is low, a vacuum gets created and air from high pressure area moves towards low pressure. And in this manner the flow of air is from high pressure to low pressure. Students, let us now discuss the activity of the flying lantern. Take a flying lantern and tie an approximately 5-meter long thread to the flying lantern so that you can bring the lantern down whenever required. After carefully reading the instructions given on the package of the lantern, open it and light the candle placed in it. Observe what happens. After some time, bring the lantern down with the help of the thread and put off the candle. Instructions. Please follow these instructions very carefully. This activity is to be performed under the supervision of your parents or any adults. There are some questions after the activity that we are to discuss. First, did the flying lantern start ascending immediately after the candle was lit? Here, the answer is no. After the candle was lit, the air masses in the balloon started heating up. After heating up, the air masses expanded and became lighter. And after that, the lantern started flying. Next question. What would have happened to the flying lantern had the candle got extinguished after the lantern had gone up in the air. So, if the candle would have got extinguished after the lantern had gone up in the air, the lantern would start descending downwards as the air masses in the balloon will start to cool off and become denser. Low pressure is associated with cloudy skies and wet weather. Now, why is that? Because the area where there is low pressure, the air masses rise up, which results in formation of clouds and wet weathers. High pressure is associated with clear and sunny skies. Because the area where there is high pressure, the air masses flow closer to the surface, which gives us clear and sunny skies. Students, let us now have a quick recap of what we learned today. Firstly, we saw what is air pressure. The pressure exerted by air on a body is known as air pressure. So, the air around you has weight and it presses against everything it touches. That pressure is called atmospheric pressure or air pressure. We also learned that atmospheric pressure is measured with barometer and air pressure is measured in units of millibars. Then we learned that air pressure is not uniform on all places on the Earth's surface. Air pressure keeps on changing from time to time. Also, the altitude of a region, temperature of the air, and amount of water vapor in the air are some factors influencing air pressure. Next we discussed is altitude of the region and air pressure. So air pressure is highest at sea level and decreases with height. The Earth's surface that is in level with the sea experiences high air pressure, and as we go up, the pressure of air goes on decreasing. The proportion of dust in the air, water vapor, heavy gases, etc. is higher in the air closer to the surface of the Earth. This proportion decreases with increasing altitude. So, the air closer to the surface of Earth is denser, and with increasing altitude, that is with increasing height, the air becomes thinner and therefore the pressure of air is less. And from this we concluded that as we go up, air pressure comes down. Next we saw the relationship between air temperature and air pressure. Temperature and air pressure are closely related. Wherever the temperature is high, the air pressure is low. Horizontally, the distribution of air pressure is influenced by temperature. Here, temperature plays an important role. Then we saw the horizontal distribution of air pressure. We learned that the flow of air is from high pressure to low pressure. The reason behind this is due to heat, the air masses on the surface heats up and expands, and they start to rise up. That is because whenever air masses heat up, they become lighter in weight and so they start rising up. This creates a low pressure at the surface of Earth. Now, when the temperature is low, the air masses becomes dense, which creates high pressure. So the surface Where air pressure is low, a vacuum gets created, and air from high pressure area move towards low pressure area. And in this manner, the flow of air is from high pressure to low pressure. We are going to discuss more about air pressure in the next part of the video. Thank you, students. I hope you all enjoyed the video.